Hi, we're going to talk about ways to rotate linear polarization state without the use of any mechanical rotating devices like polarizers or wave plates. So the first solution we're going to look at, and all of these solutions, by the way, will involve using liquid crystals. This one uses a pneumatic liquid crystal variable retarder in combination with a fixed quarter wave retarder. And this provides continuous rotation for a monochromatic beam, typically providing a contrast ratio on the order of 100:1. And as the voltage is varied, we get a continuous change in the direction of linear polarization that comes out of this combination. So this is a handy technique to use. Switching time is typically on the order of a few tens of milliseconds. And these are examples of what some of these devices would look like, and these are controllers for them. There are binary solutions as well. If you just need two angles of rotation, you can use what's called a twisted pneumatic cell. And the twist angle of the polarization state is set by the twist angle of the rod-shaped LC molecules in the cell. And when no voltage is applied, this twist is established. When voltage is applied, then we wind up in a state where there is no change in the polarization direction. These devices can be set with twist angles up to about 270 degrees at least. And they can also be reflective, and they have very high contrast, and they're quite achromatic as opposed to the previous solution, which requires a monochromatic source. There is one more binary solution, which is using ferroelectric liquid crystals. These have the advantage that they're much faster. They switch in about 100 microseconds. They can only switch through two orthogonal states, and depending upon the voltage that's applied, the fast axis of the liquid crystal half-wave plate is either vertical, as shown here, or at 45 degrees. And the disadvantage of this solution is that it requires that you spend equal times at the two voltage states for this so that you have good DC balance. So this is a solution which is fast, but again is not flexible in terms of the switch angle. I should say in closing that all of these solutions involve voltages of 10 volts or less.